Hello guys, from the heart of Nairobi to the edge of the universe, this is Professor Joe. Welcome to Kenya Space Talk, where we turn stardust into stories. Just a quick one. Why did the stars break up with the sun? Because the sun needed space. And now, today I want us to talk about the birth, life and death of a star, including our sun. Now, imagine deep in space, space, we have dust and gases. Now, the gases started attracting each other through gravity. After zimeanza kuvurutana, the gases zinajikusanya pamoja, zinaform star katikati. The dust now accumulates each other na inaform rocks, dust zinajikusanya, then inaenda inaform planets, and that's how our planets were formed. As gases start accumulating at the center, mostly helium and hydrogen, zina form a spherical shape. Remember the effect of dark matter and dark energy ndo inafanya ziform spherical shape, and the star ikuangi a perfect sphere as people think. So as hizo gases zina accumulate, pressure inaanza kuform katikati. Now that pressure ina result to high temperatures because of the particles, hydrogen and helium particles, they are being compressed together. Sasa hiyo high temperature na hiyo high pressure ndio huwa zina result to an ignition ya nuclear fusion. Sasa remember, due to the high temperature and high pressure, these conditions ni favorable kwa hydrogen nucleus mbili zicombine to form one helium nucleus. Sasa in that process tunapata energy na photons. The photons ndo zinatufikianga kama light sasa, and that's how stars are born. Now stars do have a lifespan, like they also die. So unapata, like, let's talk about our sun. Our sun has a lifespan of about 10 billion years, of which it is believed to be halfway. Something fun fact, the smaller a star is, the more kanaishi for long, and the bigger a star is, the more it dies early, especially in early stages. If a star is big, is huge, so it consumes its hydrogen fast, so unapata inakufa haraka. Eventually, even our sun will die. Now, how do stars face their death? But don't worry, our sun is halfway its age. It's going to live about 5 billion years, so you're not going to be there. I don't think even your 100 generations will be here. Most probably, even human civilization will not exist. I don't know. Or maybe you would have colonized other planets or other galaxies or other universes. So, for the star to die, this is what happens. When the hydrogen is fully consumed, the star swells up and explodes. Now, what happens is, if the star is very small, huwa kana peel off, kanatoka ngozi kama waru, and what is left is something we call a white dwarf. When the star is bigger, this is where they go out with a lot of drama. So what happens is, when a star is big, it swells up and inalipuka. Ikilipuka, ina result to something we call a neutron star. Or if the star was huge enough, ina form something we call a black hole. A black hole is something interesting. We are going to talk about it in our next segment. So at the end of the day, a star is going to be left either a white dwarf, a neutron star, or a black hole. And remember, just a spoon of a neutron star is equal to the weight of Mount Everest. Most of them have the same gravitational force as a black hole, meaning they have the same density. Now, did you know we all came from stardust? As the star underwent supernova, remember, at that high temperatures and high pressure, elements will start forming from hydrogen and helium, such as carbon, iron and calcium. And remember, your bones are made of calcium, and your blood is made of iron, and these elements, they were formed in the core of a star that exploded, and we were formed. So when somebody asks you where you came from the core of a star that exploded. And now let us enter into our last segment, where this is the time I like answering some of the comments which are related to our topic of the day. So our first question is, can we see a star being born in real time? A star being born, this is something that takes billions of years, but with strong telescope like James Webb telescope, you can be able to spot far distant stars being born. Remember, it's not happening now. This is something that took billions of years, but the light from those stars being born or dying or undergoing supernova is reaching us now. So with stronger telescope, yes, you can observe a star being born. Yes. But now another question, will the sun become a black hole? No, the sun is not big enough to become a black hole. Maybe it's going to become a white dwarf. It's going to swell and its outer layer is going to peel off and it's going to be left a white dwarf. Now, what's popping about our topic of the day? In the Corona Borealis constellation, we have a binary star system which has a white dwarf and a big red giant. The small dwarf normally sucks hydrogen from the big red giant. Now, after the small white dwarf sucks hydrogen, it tries to ignite nuclear fusion and it cannot hold the reaction, so it explodes. And that normally happens after every 8 years, and we are about to observe it now. Just a question, do you think there is life in other planets out there in the Milky Way galaxy? As you think about that, see you next time.